Hey guys, welcome back for another LeetCode 75 study plan series problem. Today we're going to be doing lowest common ancestor of a binary tree. So we're still in our depth first search binary tree category, but this is the last problem of that set. For our instructions, we're given a binary tree and we need to find the lowest common ancestor of the two given nodes in the tree. According to the definition of lowest common ancestor on Wikipedia, it is defined as two nodes P and Q as a lowest node in T that has both P and Q as descendants, where we follow a node to be a descendant, where we allow a node to be a descendant of itself. Okay, basically, we're given two nodes in a binary tree, and we need to find the lowest common ancestor of those two nodes. So, for example, if you're a visual learner, we can use this right here to kind of show you how it works. So we're given P5 and Q1. Right here, 5 and 1 are the values, and then our output's going to be 3 because 5 and 1 both share the ancestor of 3, and you can't go further down than the root of the tree. So that's what we return. And then right here we have 5 and 4. So 5 and 4 are right here, and then we're actually outputting 5 because the ancestor can be one of the nodes P or Q, because it can include itself. That's part of the least common, or the lowest common ancestor rules. Let's go ahead and talk about what we're going to be doing for our implementation strategy for this problem. So basically, we want to use recursion, right? We're still using depth first search. So what we're going to do is we're going to traverse through the left and the right of the current node, and then we're going to find either node P or Q and return true when we do. And by the time we're back at the current node, we would know if either of its subtree contains P or Q. If they do, then this node is the first instance where one of the nodes P or Q is found on both the left and the right subtrees. Then it's the lowest common ancestor. Let's go ahead and start with our implementation. First off, we're going to need to have some class variables that are going to be able to be accessed by all the methods in our solution class. We're just going to have two methods, right? Our provided method, lowest common ancestor, and then we're also going to create a depth first search helper function that we're going to call in the lowest common ancestor method. To begin, let's start with our tree node, lowest common ancestor. We can just call it LTA for short, and we're going to set this to null for now. And then we're going to have our tree node Q and our tree node P, just because we want these to be global variables that we can access in the helper function. We need to declare them outside of the lowest common ancestor. Basically, to kind of set the values that were passed in for P and Q, let's go ahead and just do that real quick. So it's just going to be this dot Q equals Q, and then this dot P equals P. So if you guys aren't familiar with this keyword in Java, it's basically just talking about this dot Q refers to this right here, this value that we declared as an instance variable, and then it's setting it equal to the value that we're passing in, right? Here, what we're going to do is we're going to call our depth first search function. So we can just call this depth first search, and then we're going to pass in our root node, and then we're going to return our lowest common ancestor. I keep wanting to say least common. All right, so now what we need to do is the main part of the solution, which is creating our helper function. This is going to return a Boolean, right? Because the reason that we're returning a Boolean is because we're going to return true if we find either P or Q. So let's do Boolean return type, and then we're just going to call this DFS, and then we're going to pass in a node. Okay, so basically we want to check if the node is null, and if it is null, then we return false. Okay, and then now what we want to do is call recursively on the left and the right side. So we'll set up two Boolean values. So Boolean left found equals DFS node.left. Oh, I can't type today. Okay, and then we're going to do that for the right side as well. All right, now we're going to check if the current node is P or Q. So if node equals P or node equals Q, we're going to want to create a nested conditional statement if left found or right found and our lowest common ancestor is null, then we're going to want to set the lowest common ancestor to that node, right? So basically we're calling recursively and then we're checking if one of those child nodes is going to be P or Q. If it is, then we can set that current node to the lowest common ancestor. Okay, and now outside of this, we want to return true because that means we found the lowest common ancestor. Okay, so in this conditional statement, we just check if the left or the right is found, but we also need to check if the left and the right is found. So if left found and right found and the lowest common ancestor is null, then we're going to want to set the lowest common ancestor to the current node. Okay, and then at the end of this, we're going to return a Boolean condition if left found or right found. All right, so let's go ahead and run this. All right, so we passed our first three cases. All right, so we passed all the test cases. So that is the solution. And for the time and the space complexity, our solution has a time complexity of big O of n, where n is the number of nodes in the binary tree. This is because in the worst case, we might visit all of the nodes in the binary tree once. And then for the space complexity, our solution has a space complexity of big O of h, where h is the height of the binary tree. This space is due to the recursive stack. In the worst case, for a skewed binary tree, the height might become n, and hence space complexity can also go up to big O of n. So in worst case, it's big O of n. So thank you for watching, and this is a great problem to get familiar with recursion in binary trees, so make sure to practice it on your own, and I'll see you in the next video.